Hello, welcome to Unit 3, Lesson 5, Introduction to Linear Relationships. During this video, if you have any questions, you guys are welcome to pause the video and then raise your hand and ask me for help. And that's the whole reason for us to do flip video, because you can learn on your own pace. And if you got it, then you can just keep going on. Alright, moving on to our next slide. By the end of this lesson, I can compare and contrast proportional and non-proportional linear relationships. I can interpret features of the graph, so that means you guys can explain the graph, and that's what we're going to do by the end of this lesson. First part right here, find the value of 2 and 5/8 divided by 1/2. The reason why we are doing this is so that you guys can mentally solve a problem using structure, patterns, fractions, and division. And you guys will be able to share a variety of strategies for division. There's so many ways to do it. And you guys will have the opportunity to think about the meaning of division. Now go ahead, turn and talk. So you guys are going to pause this video. You guys are going to work with your partner to find a value and then answer your answer. Your answer could be a mixed number, improper fraction, or a decimal. These are the 4 ways that you guys can find the answer. So I think most of you guys are going to use the first one, multiplying by the reciprocal. And how we get that 21/8 is to change that mixed number into improper, keep, change, flip, and that's what the first one is. And then the second one, distributive property, we're just like distributing the 1/2 to the 2 and then the 5/8, and then you do it that way. Or you guys can use pictures to show how many halves in the 2 and 5/8, or change them into decimal and then do long division. Okay, there are so many ways to do it, and these are all correct. Moving on to 5.2, stacking cups. In this picture right here, it's different than the one that on your paper, but just looking at this one, how many cups do you see and how tall the stack is? Okay, you guys can double check the answer with your partner and then type it in. So looking at this picture right here, we have 6 cups and 15 centimeters. That's the height. Make a prediction about the height of 12 cups. What do you think how tall it's going to be if we have 12 cups stacked up like that? Okay, talk to your partner, think about the answer, and then we'll move on. All right, now we stack the 2 stacks of the cups together. So this stack right here, we have 6 cups. And then the other side, we have 12 cups. So the one with 6 cups, the height is 15. Okay, so just like it's the same as the first picture. And then this time I actually stack it, take a picture. Then now the height is 23 centimeters. So that's the height right here, 23 centimeters. How many cups are needed for a stack with a height of 50 centimeters? So if I want to have 50 centimeters, how many cups it is going to be? Okay, how many cups I need to stack up in order for me to get to 50 centimeters? All right, now this is the answer right here. You would need 33 cups to get to 50 centimeters. One way you can do it is by making a table. If I know 6 cups is going to be 15, and then 12 is 23, then I can use this relationship. This is adding 6, right? I can use this relationship to kind of predict my answer right here, right? And then on the other side, I am adding by 8. So again, using the relationship, and I'm just like predicting what it's gonna be for me to get to like the height in 51, and I know it's gonna be 33 cups. Okay, again, there's so many ways to do it. I want you guys to tell me, how did you guys find the answer, or how did you guys try to find the answer? All right, next page. Okay. summarize. You might observe that the height of the stack grows regularly with the number of cups, right? Well, we know that's like a pattern, right? Which is like, let me go back, adding 6 on the number of cups and then adding 8 on the height of centimeters, right? We see the patterns right here. But this relationship, it is not a proportional relationship, okay? This is not proportional, and then we're going to find out why. All right, let's go ahead and graph this on your notes. So if you guys flip to the back, you guys will have that graph as well. I have my table on the screen for you guys, so you guys can go ahead and graph it. Your graph should look like mine. What are some ways you can tell that the number of cups is not proportional to the height of the stack? So we talk about this is not a proportional relationship, and then one way to look on the graph is that my line does not start at 0, 0. If the relationship were proportional, then the line would pass through the origin. Since this one did not, so I know it's not. The second reason is if I'm looking at the coordinates right here, they should be constant, they should be the same. So, but when I divide them, they are not the same. So I know that they are not proportional. Okay, so the 15/6 is from the coordinates right here. Remember before we did the rise over run, so y over x, and then if they are the same thing, they will be equal to each other, but they are not, so they're not proportional. What is the slope of the line in your graph? What does the slope mean in this situation? How do we find the slope from a graph? Do you guys remember? Remember we have those like slope triangle, right? Just pick 2 points and then you just count how many we go up and then how many we go to the right. So it will be the same thing right here. I have the answer on the right, but let's go ahead and how to do it. See how to do it. Go up and then right. So if you look at your graph or look at my screen, let's just gonna see how many boxes right here. This will be, or I can just do like 23 minus 15, then I would know this height right here. 23 minus 15, that's 8. So I have my rise is 8 over my run will be 12 minus 6, so it will be 6 right here. Okay, so 8 and 6. So I have 8 and 6. I can simplify it using 2. So I have 4 over 3. And I can double check with the other point. So all the way, rise over run. Your line should be straight. Unlike mine, yours should be straight. But if there's like too many boxes to count, so it can do the same thing. The rise right here, so your letter to go up is your Y. So what's the difference between 51 and 23? 51 minus 23, which will be 28. And then your run, how wide your letter is 33 minus 12. So over 33 minus 12, and I'll get 21. So same thing, I can simplify them using 7. 7 goes into 28 4 times. 7 goes into 21 3 times. So both of them, I'll have the same slope. So I know the slope will be 4/3. At what point does your line intersect the vertical axis? This is your vertical axis right here, your y-axis, right? This is your vertical axis. Let's see. So on my y-axis right here, oh, again, it should be one straight line, but it's so hard to do on a computer. This is the point where they meet. So it is 1, 2, 3, 4, 5, 6, 7. So I meet at 7. What do the coordinates of this point tell you about the cups? remember when we like stacked those cups, we did not start from 0, 0, because when you put one cup up, let's say this is a cup right here. So it's just one cup. I'm not starting out from 0, right? So this could tell me that, hey, my starting point is at 7 centimeters, right? Because maybe that's how tall the cup is. And that's what that means. So coordinate is 0, 7. That's what you're going to write it down. If we have 0 cups, the height shows that 7 centimeter, but this does not make sense if we think about the number of cups in the stack. However, we notice that each cup has a rim, then 7 centimeter is the height from the bottom of the first cup to its rim. Okay, so that's the meaning of it. How much height does each cup after the first add to the stack? So after the first cup, and then how many centimeters that we are adding onto that stack. So each cup is adding 4/3 centimeter after the first one. And again, how do we know this? Because this is the slope, right? That is our rate of change. Okay, so this tells us every time I put one cup on top, then it adds 4/3 centimeters on it. Okay, 4/3 means like 1.13. If it's better to know like decimal point, that means if I stack, let me go back to like the pictures and we can look at it. So each time this rim right here, it will be 1.3333 centimeters. Put another cup, this rim right here, 1.3333. Same thing at 1.3333. The reason I don't use the decimal number, because if I use a fraction, it's just easier for us to grab, and it's easier for us to know the number without like rounding it, so we have more accurate answer. And again, just like what I said previously, in algebra, you would like to use improper fraction than decimal. All right, let me go back. And that's it. So make sure you do your practice on Canvas and then take it. And then that's it for today. If you need help, if you have questions, you're welcome to work with your partner, your table mates on your practice. Raise your hand, ask questions, and let me know.